And we want to calculate arc length. In order to calculate arc length, we take that little thingy called ds, and we have to calculate how much ds is, right? Okay, ds, I'm going to do it on this side. ds, if you don't remember, was this. Dx squared plus dy squared, right? But in this case, instead of factoring out x out here, this is dt, because we're in parametric mode, right? So this thing becomes dx over dt squared plus dy over dt squared, eh? Now, then we have to know what this dx over dt and dy over dt is. So it looks like we are going over here and figuring these out separately. Do you remember x and y of cycloid? X was this, and then y was this. Oh, you know what I'm saying? Okay, so we'll get it from here. So dx over dt is r, and then we have 1 minus cosine t, like that. Okay, and then dy over dt is r, and then sine t. Say yes. Okay, we'll take those two and shove it in here now. So then this becomes, unfortunately we have to square that, but we can factor out r. So r can stay out here. And then we have 1 minus 2 cosine t plus cosine squared t plus sine squared ta. You with me? And dt. I always forget that dt part. Well, somebody tell me what that is, right? Why are you so quiet today? This class is never this quiet. What's going on? And then, looks like we are stuck. Does anybody know how to integrate that thing? I'll take suggestions. Feel free to use your microphone.
What about power reducing formula?
Oh my God, right? So here's a tactic. In math, you can generally write down whatever the hell you want to write down, which is this, right? And then we have to adjust it. What can we put in here so when we distribute inside, we get that previous line back? Somebody say it. Okay, do you see you want to put 4 in there, right? If you put 4 in there, then cancels the denominator, then you will have this leftover 2. You know what I'm saying? So 2 in here will do. You with me? Too much algebra? Okay, then tell me what this thing is. That thing is cosine, that thing is half angle formula for sine, isn't it? So we have sine t over 2. So far, so good. Say yes. No. Yes. Okay, now we have to worry about this, by the way. Plus or minus thing. Let's talk about this. Okay, t will vary from 0 to 2 pi, right? In order to make one revolution. Now this is sine t over 2. So 0 to 2 pi. Do you see that is t over 2 will vary from 0 to pi? And sine from 0 to pi is still positive, first and second quadrant, so we are okay, eh? Too much algebra again?
Can you explain that one more time, the last two sentences?
Okay. So our t will vary from 0 to 2 pi, right? Right.
Yeah.
Then if I do this, then this is true, right? Then if we take sine, it becomes this, right? Is this thing all positive, is what I'm saying. Sine 0 through sine pi, that's always positive. It's never negative. It's like at worst 0. You know what I'm saying? So we don't have to put absolute value. You get it?
Yeah.
Okay, now we are ready to integrate that sucker now. So our S is equal to from 0 to 2 pi of that thingy to R and sine. You know, I always suggest that you simplify everything, then put it inside the integral like that, right? Okay, then 2R out here. What's the antiderivative of this thing? Let's see if you still remember your antiderivatives. Somebody jump in and say it.
Negative cosine t over 2.
Is it t over 2? Oh, cosine t over 2? Aren't we missing tiny little thing?
Yeah, the chain rule, so then it would be 2.
Yeah, like that, right? Okay, you have to be careful now, because usually when you have sine and cosine, 0 to 2 pi, yeah, that just gives you the same thing, but this is t over 2 now, right? I mean, if the arc length turns out to be 0, I would feel pretty bad. Okay, so if I put 2 pi in, that's cosine pi, right? That gives me negative 2. Right? No? Yes? Maybe? What is your weird expression? So the whole thing is 8R? Right?